That's more of a math 3 concept. I don't know right this second. Can we just skip through the notes, please? Then we'll worry about where it clues in. Okay. Yes, TJ. Can you what? Go get what? Can you do this one? Give me 1 second here, friend. All right. So we're going to go back over adding and subtracting. We're going to go back over multiplying. And then I'm going to teach you something new today. So to add polynomials, we need to combine like terms. So TJ, where do I put 9x when I move it? What does 9x go with? 3x. Where does the 4 go? Okay, so when I add it together, we get 5x squared plus 12x. You tell me. -7 plus 4. -3. Oh no. Okay. Are we good with adding?
Yes, ma'am.
Subtracting. Again, the biggest downfall is going to be remembering to distribute that negative through before you combine like terms. So, when I distribute my negative through,
-6x squared.
-6x squared.
Squared.
This becomes
Negative 3x.
-3x, and this becomes +1. Okay, so remember, listen. When I distribute the negative through, it switches all of my signs. So everything that was positive became negative. Everything that was negative became positive. Yes, we did. Oh, you're right, I did. Oh, no. TJ said, oh, Miss Smith, you put it in the wrong spot. And then Vanessa's up here going, he did.
Does that make sense? What did she put in the wrong spot?
There wasn't a place spot for the x.
Yeah, very good.
Good.
Very important.
You know what you were doing.
No, honestly, I didn't pay attention. That was an honest mistake on my part. I mean, I'll take claim. Yes, I did that on purpose to see if you were paying attention. Not. Listen, I'm not going to lie to you. Again, teachers make mistakes. We are human. We are not perfect. Here's my mistake. I'll toot my horn when I can, but I make mistakes too. All right. So, y'all said, well, hold up a second, Miss Smith. That means my 6x goes here. My -3x goes here. And my +1 has nothing to go with it. Okay? So, again, it's very important that you pay attention to your exponents and that you're combining like terms. Gusto, please pick up your head, my friend. Hi.
Good morning.
Okay. So 7x cubed plus 2x squared minus 4x plus 1.
Next.
So this is what you're going to do if you ever have to do perimeter with polynomials. So all of that homework assignment that you had for the past 2 nights, with the perimeter and area, this is perimeter problems. Adding or subtracting depending on what's happening. Okay. So perimeters all add. The subtraction's actually going to come into place when you're doing the area and we got to cut out those squares because you have to take those away. Okay. So all of this can be applied to those application problems we've been working on for 2 days. Okay? All right. Flip one more time. Okay? Now we're going to multiply. When I multiply polynomials, here's some reminders. 1, we have to distribute. 2, we multiply your coefficients. And 3, we add your exponents. So I need to distribute when I have a monomial times a polynomial. My 2x multiplies against everything. So 2 times 5 is 10.
Oh, right.
And then, yes, x cubed. Because we add the exponents. Remember, x has an exponent of 1. We take 2x times negative 2x.
4x squared.
Squared. Plus 18x. Ta-da! Listen, it's not that these are easier than what I give you. I'm not sitting here going, okay, now what's next? Okay, now what's next? You need to start asking yourself the questions that I ask you in class in your head. Okay?
You want to go back up right fast? I have to erase.
I got you. You good?
Yeah, thank you.
You're welcome. Binomial times a binomial. This is where we had to FOIL. So, we do first. So 3x times 5x. 15x squared. Remember, that's x to the first and x to the first, so that's x to the second. We then need to multiply my outer terms. So 3x times 7, 21x. Then I multiply my inner terms. So negative 4 times 5x, negative 20x. And finally, my last term, so negative 4 times 7, negative 28. Okay. Basically,
That's the answer.
no, not yet. Combine like terms. So 21x and negative 20 becomes just 1x or x. Okay, so basically foiling is taking 3x and multiplying it by everything and taking negative 4 and multiplying it by everything. Okay, so that's all you're doing is multiplying everything that you can together. Okay, so we haven't done one of these, but we're going to try one.
Oh my gosh.
Oh my gosh. Oh no. Now I made your second polynomial a trinomial. Okay. So this is really not any harder than multiplying a binomial times a binomial. Okay. You're going to take every piece of that binomial and you're going to multiply it by everything inside the trinomial. So what I mean by that is you're going to take 2x times x squared. That becomes what?
2x cubed.
2x cubed. Add your exponents. Okay. Teacher, you don't have to get so angry about it. Calm down.
Just make me mad when they ask me a question.
Anybody's being ignorant, it's you by getting angry over her asking a question. Calm yourself, friend. Okay.
14x squared.
Don't forget the negative 14x squared, because that's 2 times a negative 7. Okay? And then you said what? Plus 16x. Okay? So you multiplied everything with that 2x.
Yep.
Now I need to multiply everything with the 5. So 5 times x squared?
5x squared.
Negative 35x. Good, Seth? And you said positive 40. Okay. Whoops. I got to shrink this a little bit. You can't see it all. My bad. Okay. So now the problem.
That's a big problem.
The problem is now when I combine like terms, I have more than one set of like terms. Okay. So 2x cubed has nothing to go with it. But I can combine negative 14x squared with 5x squared. Negative 9x squared. I can combine 16x with negative 35x. You said negative 19. And then 40 goes with nothing, so we just bring it down. Final answer.
Why is there an x with a 40?
Huh?
Why is there an x with a 40?
Because 40 is 5 times 8. So it's a constant times a constant. So there was no variable there to begin with. Does that make sense?
Could you put an x?
No.
You're changing the term if you do that. Adios. Okay.
I'm starting to get it a little bit better. Hello.
That's your job.
Minus Saturday.
But the problem is her kids are split between my class and 2 other classes, so she only gets a half an hour in each class.
If I remember, I'm texting you. You know I'm gonna blow you up. You look for me. Okay.
All right. So, you all asked, are we going to divide?
Oh.
Okay. The answer is yes. But
Why you wait till now to answer our question?
Oh my god.
because we need this to do the next part. We didn't need it before.
Yeah, we did.
Okay. So, the answer is yes, but we do simple division in Math 1.
Why?
You will not get to the complex division until you hit Math 3. Okay. So all we do when we divide in Math 1 is we divide by a monomial. In Math 3, you're going to divide by binomials and trinomials, and maybe even 4-term polynomials. Okay. So we do the simple. So we need to take this piece by piece. Okay. So it says when I divide by monomials, I divide my coefficients and I now subtract my exponents. Remember, if I had x to the 4th divided by x squared, that became x squared because 4 minus 2 became a 2. So let's take a look at this. I need to divide each one of these terms in the top by this term in the bottom. So we're going to take the coefficient first. What is 24 divided by 8?
3x cubed.
Okay. First off, I didn't ask for the x yet. So I need you to stop. Because again, you may be ahead of the game. I need to keep everybody else on the same page. Okay. When I divide, I have to subtract my exponents. So I have x to the 5th divided by x squared. So that becomes x to the 3rd or cubed. Okay. Now I divide the middle term by this. So what is negative 40 divided by 8? Negative 5. X cubed divided by x squared. Just x. They read the coefficient with it is what they were doing. Okay. Then I divide my last term by this. So 16 divided by 8 is 2. Just 2. Why does x squared over x squared disappear? It goes to a 0, and anything raised to the 0 power is 1. And 2 times 1 is just 2. Okay. Yes.
How do you know that you have an X?
How do you know you have what? An exponent of 2?
That's your exponent.
Your exponent is whatever the x is raised to.
How do you know that that's what you're raising the 8x?
Because that's what's written there.
Like whenever you
No, I'm trying to answer your question, but I'm not quite sure I'm understanding. So I mean, if I wrote it 8x cubed, it's raised to the 3rd power.
how do you know how it's raised? Oh. Because you just you subtract. Like let's just say that 8x squared. How do you know?
So in other words, you want to know if I had
So basically, you divide all
you want to know how do I get this? They're going to tell you what that is. They can't tell you to divide a polynomial and not tell you what to divide it by. Hold on. You're going ahead of me, Alexis. Hold on. All right. Okay. So, Alexis had a very good question. She said, if they don't tell you what to divide by, how do you know what to divide by?
1.
You know what to divide by finding something called the greatest common factor. GCF. You should have learned this back in what? The 6th grade?
Yes.
Okay. So, take a look at my 2 numbers. What can I divide that goes into 18 that also goes into 21? 3. So, we're going to divide this by 3. What does that leave me with when I divide by 3? 6. X to the 5th minus 7 x squared.
Why would I divide by 3?
Okay, that's the biggest number that divides into both 18 and 21. Okay. Hold on, we're not done yet. Okay, now we need to decide what x's I now need to divide by. So I have 5 x's and 2 x's. How many can I take out of both that would be the same?
Wait, what?
Hold on. Let me say that one more time because maybe I worded it wrong. Hold on. You have x to the 5th. So you have 5 x's on the left and you have 2 x's on the right. How many x's do they share in common?
2.
2. So we divide by x squared.
So you basically just pick the smallest exponent?
Amen. That is it, my friend.
That's what I was asking you.
Yes. Okay. So did I answer your question now? Okay. So now, when I divide that, I'm left with 6 x to the 3rd minus 7. And your greatest common factor is 3x squared. Your greatest common factor is this and this. Everything that you divided out is what we call your greatest common factor.
Wait, can you
Oh, sorry. There you go. That's your greatest common factor. Is everything that you're able to divide out of your problem. Everything that your problem shares in common. So, this is your first step of what we're going to cover for the next 2 days after today. We're going to do everything on factoring from now till Friday.
Are you going to the game this Friday?
I am not. Hey. Guys. Come on, we were doing so well. We have 2 problems to get through, and I'm done with notes for today. Yeah, we'll leave the rest for tomorrow.
We just doing these last 2?
And then we'll finish the rest tomorrow.
I want a worksheet. I did the working tools.
I'm just waiting so we can get through some notes.
These are notes.
So we're doing the same thing like we did at the
I think this is classwork.
Andrew, when I am instructing, that would be notes. Classwork would be you working independently on your own after I'm done instructing.
Miss Smith.
Okay, so hold on. Let me get through this first, please. Unless it has to do with my pencil broke, my paper caught on fire. I don't know. Okay. All right. Number 8. I have 30x squared plus 35x. What is the biggest number that divides into 30 and 35? 5. So we're going to divide both of these by 5. So that leaves me with 6x squared plus 7x. Okay. My left term has 2 x's. And my right term has 1. How many do they share in common? 1. So we divide by x. So I'm left with 6x plus 7. So my GCF is 5x. So when I write this as a factored expression, it looks like this.
Right.
So what you're doing is everything we've done for the past 2 days, you're doing the reverse of that now. So for the past 2 days, I taught you how to take 5x and distribute it through. Now I'm showing you how to pull it back out. So we're doing everything we did for the past 2 days in reverse. And actually, I lied. I have one more worksheet because I got some really hard ones that are going to be lots of fun to do.
Yay.
They're fun. Okay, take a look at this one. Factor the expression below. What does 9x squared and negative 49 share in common?
3.
2.
3.
4.
1.
1.
A 1. They don't share anything in common. Do they share any x's in common? So as of right now, you cannot do anything with this one, so I want you to stop here. I'm going to show you, this is a special one that we're going to learn about tomorrow. Ooh! Okay, so please glue this in on page. We are on 91, you are correct. While you're gluing that in, I'm coming around with this hard one. It's got 4 problems. I had to make it a little bit more difficult, you know, because these are pretty easy. What?
Hey.
I have a quarter. Can I get some glue? I got
For me?
stick, but I got a dog.
Told you. Told you.
Who's so?
What? Miss Smith, I didn't do those yesterday. Ready to go yesterday?
I said, what?
Because I'm 90, right? But why you won? The one that we just used.
No reason.
This-
Wait, what?
Is it all right, Arlie? No. Who lost their sheet already? Hands up. That's mine. Yes.
Do they always have to be served in order?
What do you mean?
Like the cube and the.
It should always go cube, squared, x. They call that descending order. All right. So when this one is finished, it's going to be folded up like a booklet. Okay. And it's going to glue in on page 93 when we're done. Sorry, 92. my bad.
Are we doing it
92.
together?
Okay, we're gonna do this together. So now, instead of dividing 2 or 3 terms, woo, we gonna make it a little bit more difficult. So now,
I want them all. I want them all.
I have 18, 15, 3, and 6.
3.
I can divide all of these by 3.
I have one. Can we do some work?
Wait, so we don't change the order?
You can. Okay.
So then it'd be 5.
Andrew, do I need to move your seat again? Okay, so Sabi looked at this and said, it's out of order. Okay, so let's put it in the correct order now. If you notice, your y squared comes before y to the third. Those should be reversed. So when I divide, I'm going to shift everything. So my y cubed should come first. So negative 15 divided by 3 is negative 5y cubed. Then my x squared should come. So 18 divided by 3 is 6. Three divided by 3 is 1, or just y, and negative 6. Okay. Do they share y's in common? Every last term has to have these y's.
1.
No. You can't divide out any y's because this term doesn't have any.
Oh.
You can only divide it out if every one of the terms has them. So you are finished. So all you do now is put this in parentheses and your 3 comes out front. Yes, your GCF just goes to the outside. You know, like bubble guppies. Outside, outside,
No.
outside, everybody outside.
Bubble guppies? What time is it? It's time for lunch. Something like that.
All right, take a look at this one. Whoa! Now you got X, Y, and Z's. Okay, so numbers first. Okay, numbers first. 45, 1, 15, and 5.
They have no comments.
They don't have anything in common. Why?
Oh, there's a 1. That one
This
has-
coefficient of a 1. You can't divide anything. You can't divide 1 by anything but 1. And dividing by 1 will do nothing. So there is no coefficient to divide. Okay? Take a look at your x's. I have 3 of them, 1 of them, 2 of them, and 1 of them. How many do they share in common? 1.
One.
So we divide by x. So that's 45. X cubed becomes x squared. Notice I don't mess with anything else.
So x cubed is with the 3, right?
Yes. This x cancels out, so I'm just left with y squared, z. 15, my x squared becomes x. My y doesn't change. And I lose my x in my last term.
I want the exit here.
Huh?
Oh, never mind.
Not yet. We'll do that all at the end. Okay. So look at your y's now. 2 y's, 2 y's, 4 y's, and 1 y.
1 Y.
1 y. So I can divide out a y.
Your Y goes with.
So 45 x squared.
Y1.
Husto, please stop talking while I am. Y squared divided by y becomes y. Bring down your z. Minus y squared becomes y. Bring down the z. Bring down the 15. Bring down the x. Y to the 4th now becomes y cubed. Negative 5. My y disappears, and I'm left with z squared. Okay, take a look at your z's now. I have 3, I have 1, I have none, and I have 2. You can't do anything. You can't do anything because this term has no z. So we did our numbers, we did our x's, we did our y's, we did our z's, so we're finished. So we put parentheses around this. This is what's left. And the 2 things that we divided by were x and y, so they go out front. And you're done.
Your greatest common factor.
That's your greatest common factor. Your greatest common factor are the things that you divided by. So your GCF for this is x, y.
Bro.
Oh, God.
They're not too bad, right?
No, it's so many.
Okay, so when it gets difficult is when they give you huge numbers and you can't figure out what to divide by. The variables are pretty easy. It's when they give you like 108, 764, and you're like, I don't know what to divide by. Okay, let's look at this one. 32 x to the 4th minus 16x cubed plus 8x squared.
Divided by 4x squared. 2.
Daniel, say that one more time.
Which one?
What you said first.
8.
Divide by 8.
Oh.
This is divisible by 8. So, all right, stop. Okay, it's divisible by 8, but most of you said 4. So let's do 4. Let me show you what happens if you don't divide by the biggest number, okay? Because sometimes you're not going to. So, yes, I want you to write this. So, most of you said 4. So, what's 32 divided by 4?
8. It is 4, right?
8x to the 4th minus 16 divided by 4 is 4. And 8 divided by 4 is 2. Uh-oh.
You all have X.
Look at my numbers again. 8, 4, and 2. What are those divisible
Oh.
by?
By 2.
2. So I need to divide by another number because I can still keep going. So then this becomes 4x to the 4th minus 2x cubed plus 1x squared. So when you have to pull out more than one number, we multiply those together. So 4 times 2 is 8. So your greatest common factor is actually 8.
But it still works.
So it still works to do it separately. You just have to remember to go back and multiply those numbers together.
That's easy.
Okay? So that's okay. And again, when you get those bigger numbers, you might have to use divided by 2, then divided by 4, because they look too big and it's hard to determine what they're divisible by.
So then it'd be that, and then on the outside.
Okay, but we're not done yet. How many x's do they all share in common?
What?
2.
What?
2. Thank you, Sabi.
Oh, I'm sure.
We can take away 2 x's from each one of these. So 4x squared minus 2x plus 1. And then my greatest common factor is 8x to the second. Yes.
You go back up.
Yes.
I thought it was like greatest common factor is 8 because 8 going 7.
It is 8.
I'm talking about 4.
What?
Here,
Yeah.
it is 8.
And 4.
Because you can separate it. Seth, I just got done explaining this. Do you listen at all when I speak? Or do you just do and then come back at me with the same questions that I just discussed? So I told them, sometimes it's not easy to always just look at it and find the greatest common factor. Most people may not be able to look at 32 and say it's divisible by 8, but they know it's divisible by 4. So it's okay to divide out by smaller numbers. But when I do that, the numbers that I divide by then have to be multiplied together to get that greatest common factor, which you know is 8. So you can divide by 8 right away, or you can divide by 4, then divide by 2, and you still get 8. Okay. All right, last one. 82, negative 16, and 8.
Two.
If you struggle with this because you've got that 82, look at them all. They're all even, which means they're all automatically divisible by what, Husto? 2. So let's start at 2. That's okay. So 2. So that takes me to 41, x to the 4th, y squared, z to the 3rd, minus 8, x to the 3rd, y to the 7th, z to the 11th, plus 4, x squared, y to the 9th, z to the 2nd. So now look at your numbers again. We got 41, we have 8, and we have 4. 41's prime, you can't divide it. So 2 was it. You're trying to look for a bigger number that did not exist. Okay? So let's divide out our x's. How many x's do my terms share in common?
1, 2, 3. There's
2. You've got 4 in this term. You've got 3 here and 2 here. So they share 2 in common. So 41, x squared, y comes down, z comes down. Minus 8x, y comes down, z comes down. Plus 4, my x's become 1, so they're gone. Y comes down, z comes down. Okay? My y's, I have 2, 7, and 9. So I can take out 2. So again, 41, x comes down, z's go away, or I'm sorry, y's go away, z's come down. Minus 8, x comes down, 7 minus 2 is 5. Z comes down, plus 4, 9 minus 2 is 7, z to the 2nd. Woo! Almost there. Okay, so
This is not a test. I'm
this
just
may not be
testing.
hard, but it can be a long and grueling process. Some people, when they get to this and they get to the variables, they do all the variables at once. You can do that. Okay, I'm taking it step by step for those that need that. So if you want to do your X, Y's, and Z's all at the same time, you can. How many Z's am I removing? 2. Again, I have 3, 11, and 2. So 41 x squared. I'm going to bring this up some so you can see it. 41x squared, z to the third becomes z. Minus 8x, y to the fifth, z to the ninth. Plus 4y to the seventh, and z's are gone. I'm now done, and my greatest common factor is 2x squared, y squared, z squared. You ran out of space.
Go down, please.
How far do I need to go down? Right before this, we divided by 2. Right before that, we divided the original problem by 2.
I just turn around and see all that word. That's what happened. You pay attention.
Oh, snap.
I'm already done.
Bruh, I need to work on this one.
Good thing I have a worksheet.